Hi friends, welcome back to my channel. Still on Power Machines and 5, today we will be looking at a compressor. My name is Tsepo. Please subscribe to my channel to make sure you keep on receiving videos like this. Click that notification button so that you will be notified every time I post a new video. So today we are looking at the graph, which is the indicator diagram of a compressor. So it is very important that you do understand, or you are able to locate the movements or the actions that take place in a compressor from this graph. So this graph represents the movements of the compressor when it is compressing the air, delivering it, taking in new air, and then compressing it again. This graph is the whole cycle of a compressor. So now here we have our point number 1, where now our compressor is filled with air. So the basic structure of a compressor is a piston and a cylinder. This is the piston, this is a cylinder. So from number 1, this is the stage that is being represented by number 1. The piston is at the bottom dead center, and then we have air in the compressor, air that is at pressure number 1. Usually it's atmospheric pressure or something near atmospheric pressure. And then now from number 1 to number 2, now the piston is compressing the air that is in the cylinder. Now the piston will move up until a certain point, which is the top dead center. Now the piston will move up, and then we will have our piston here. The piston is no longer here, and then all the air that was in the cylinder will now be compressed, and then it will be compressed. Is from this point, with point number 1 to point number 2, and then the compression is performed using a polytropic process, which is PV to the power n is equals to C, and it's polytropic process. And then any information that you want from point 1 and point 2, you can get using the formulas of polytropic law, which we did in thermodynamics of gases. Thermodynamics of gases, the first chapter. So you can go to the table of thermodynamics of gases and then look for the formulas which correspond with polytropic law. So any information that you want between point A and point B, you can find them using the polytropic formulas. And then now from point number 2 to point number 3, now the air is already compressed. From point 1 to point 2, it's already compressed the air to pressure number 2 and volume number 2. So from the first point, the volume was V1, and then now it is compressed to V2. We know that when we are compressing, there will be a decrease in volume. So the volume in V1 will always be greater than the volume in V2, as we see that the volume has moved to this point, which will be less than V1. And then from number 2 to number 3, now we are delivering the air that we have compressed to whatever storage that we are storing the air, or whatever use that we will be putting the air, we will be using the air for. So from V2, from point number 2 to point number 3, we are delivering the air. But if you look at the graph, the air that we are delivering will end up in this point, will not touch our Cartesian plate, meaning now that there will still be some air in the cylinder that is left. So a compressor has what we call a top dead center. So in this point, this is the point where our piston will stop when moving up. So the top part of our piston cannot go beyond this part. And then when we have delivered the air in this part, which is where our piston cannot reach, there will still be air under pressure number 2 that will remain in the piston, will remain in the cylinder. And then we call this the clearance volume. Is the clearance volume. So the air in the clearance volume, this is the space represented by the air that will remain in the cylinder, and then it is called the clearance volume, which is CV, and then our V here is V number 3, V3. So after the delivery stroke, after the air is being delivered, the air in the clearance volume will still have the pressure, which is pressure number 2. So now from point 3 to point number 4, now the cylinder is moving down. The cylinder is now moving down to the bottom dead center. Now our cylinder is here. And then when our cylinder is moving down, the air that is in the clearance volume, this is our bottom dead center. The air that is in the clearance volume, because it's now the air was compressed when the cylinder, the piston was here. Now the air, as the piston is moving down, the air will be expanded, and then it will be expanded, and then it will be it will fill the space in the piston, in the cylinder. This is from number 3 to number 4. Only the air that is in the system is compressed, is expanded between point number 3 and point number 2. And then from point number 4 to point number 1, now one of the valves, which is the induction valve, will open, and then air will be let into the system from outside, and then this is going to be our pressure, which is pressure number 1, and then after it will close, and then now we have air in the system. We can begin our cycle again. The piston will move up, compress the air, which is from pressure from point 1 to point number 2, and then it will deliver from point 2 to point 3. After delivering, the air that is in the clearance volume will be expanded to point 3 to point 4, and then the valve will open, and then we go to point number 1, and then it goes on and on. So from here, from the top dead center to our bottom dead center, we call this a stroke volume. It's a stroke volume. So a stroke volume is from V1 to our V3, which is the clearance volume, and then the stroke volume is also called a swept volume. And from here to here, from V4 to our V1, this is called the effective volume. And the effective volume is the actual amount of volume that came into the system after the valve opened. So we already have air into the system, the air that was compressed in the clearance volume, and then the piston moved down, that air was expanded, and then after the valve opened, that amount of air that will come into the system, it's what we call the effective volume, which is from V1 to V4. This is our effective volume. And remember, the effective volume will be less than the stroke volume. You might find that your effective volume is something from here to here. So the effective volume will always be smaller than the swept volume. And then this compression expansion will also be performed using this law. PV to the power n is equals to C. So that it's the process of a compression indicated in the form of a graph. So you must learn to draw this graph so that you will be able to understand and answer questions based on the compressors. So we have formulas. A formula for work done. Work done is represented by the area covered by the graph. This area represents our work done. And then our formula, we have two formulas for work done. Let me say work done. One formula says that n minus n1 minus n divided by n minus 1 times P1 V1 divide minus V4 in brackets, and then they say P2 V2, it's n minus 1 divided by n minus 1. And then another formula for work done will be MRT. Oh, it's MR, sorry. MR n divided by n minus 1 T2 minus T1. And then we have another formula for volumetric efficiency. And then our volumetric efficiency will be the effective volume divided by the swept volume, which is V1 minus V4, and that's the effective volume, and then the swept volume is V1 minus V3. And then we have the formula for power. We know that power, it's equals to the work done per second. And then we have formula for mechanical efficiency, which is equals to the output power divided by the input power times 100. And then that is everything that we need. So meditate on this. On our next video, we will do an exercise to see how do we go about applying all this information. So one thing to remember is that these temperatures, we will be using them with the SI unit, which is Kelvin. We do not use degrees Celsius because we are dealing with ideal gas. Remember, every time we are dealing with an ideal gas, we always consider our temperature in kelvins, not degrees Celsius. So I think that's everything that we will need On our next lesson, we will do some exercise to see how do we go about how do we go about applying all this information. So my name is Tepo. From me to you, I will see you on the next lesson. Ciao.